for the final time this year. This is it. This is the last type of the circle proofs are it. No more proofs after this, other than, preparing for quiz 2, and they'll be on quiz 2, but this is it right here.
Quiz 3.
Nope. We didn't. I don't think we put a proof on there.
Will they be on the regions?
Oh yeah. Regions is divided up into 4 parts. Part 4 is 1 question worth 6 points, and it's going to be a proof. What kind? I have no idea, because I do not have any advanced knowledge of the regions. You can try to sneak a sneak peek at it. There's a vault in the main office, but kids have tried that in the past and they've gotten sniped. They come in. Has anybody ever seen how they bring in the regions? It's like a big armored car pulls up in front of the high school, and the guards get out. Some kids have tried to take out the guards in the past, and right off the roof they got sniped. So you can try it, but I don't think it's going to go well for you to get an advanced copy of the regions. And I don't see it either until the day of. So, all right, what's up, Matt?
Do they actually pull up?
Yeah. How do you think they bring those things are secure? And there's a vault in the main office. I have no idea how it opens with a combo, but if they come in right here, just like they do with everybody see them at the bank with the money. That's how they come in here. So maybe if you see them come in, you could try to take one. Who knows? But I doubt it. Kids have not ended up well in the past doing that. All right, you ready? Matt, they don't. That would be pretty cool if they rolled in just like the bank people do with the money, but no. I have no idea how they get here. They are legitimately kept in a vault. There is a vault in the main office that they're kept in under lock and key. All right, we ready here? Okay. It's going to be a little tough here today. My hope is by the time you leave class, you're like, ooh, I really got to start getting on top of my circle facts. And I'm not even done with them. All right, I'm not going to introduce any new facts today. Everything we have, we're going to apply to these proofs. But tomorrow and Thursday, I got more for you. I got more. No new ones today. We're going to apply the ones we have to the proof, but I'm going to give you more on Wednesday and Thursday. So let's get down to this. I have this circle here, circle O, radius OC, perpendicular to chord EF. Biggest piece of advice I can give you today and any other circle proof you do. Don't just be so consumed with circles. Guys, we have done 9 units before this. 9. And most of those included proofs, didn't they? Don't forget what we did in those proofs. All right? Don't forget what we did there. Just don't be so consumed. I got to use a circle fact, circle fact, circle fact. No, you don't. Remember what we did in the past, too. All right? Because that all still applies here. And what do I mean by that? Right off the bat, you guys should be putting some symbols on your diagram. It has nothing to do about circle facts. OC, perpendicular to chord, EF. Oh, they form perpendicular lines form. I should be throwing right angles up there. Don't forget about it. All right? Don't forget about it. And we're asked to prove angle CFW congruent to CEW. You guys know how this has gone all year long. That's not going to be true until what's true? Yeah, the triangles are congruent. So help me get the triangles congruent, then we can say those angles are equal. This warm weather, I guess, some ice has melted off my heart today. I'm going to actually give you steps 2 and 3. And then you're going to give me the rest. It's not much, but I'm going to tell you they're right angles and then tell you they're congruent. Don't forget about it. You're welcome. You're welcome. So angle EWC and angle FWC are right angles. Perpendicular lines form right angles. And then I'll tell you they're congruent, because that's usually what I do here. Unless it's an HL proof, I don't have to, but I have inside knowledge it's not an HL proof. All right angles congruent. So there you go, kids. I gave you an angle to start out with. I need 2 more pairs, though, from you guys. I won't call on anybody yet to the second proof, so if anybody wants to chime in because they see something, whether it be a circle proof or anything we've used in the past, feel free.
WC is congruent.
There you go, right? Hey, just like it, right? Don't forget about it. I make fun of people a lot because, oh yeah, that's all you can give me, but don't forget about it. It's still there. I don't care if we're in a circle or not. WC Congruent to itself. Reflexive. All right, so we're down to one more pair. And let's be honest here, right? I haven't used anything that had to deal with circles yet. So probably this last pair of sides or angles, it's going to have to be a circle fact. All right, going to have to be a circle fact. And you guys that weren't here yesterday, watch that video because we're about to use something we talked about yesterday. Ian, what do you got?
Is EC congruent to CF?
Why do you say that?
Like, because the angle and then the arc. And then, like, if the arcs are congruent.
Why are the arcs congruent?
Well, if I thought the arcs across from, like, the angle. Like that.
If they're central or inscribed, yes. But I see what you're trying to do. See these right angles? They're not central because they don't come from O. And they're not inscribed because they're not on the circle. So I know what you're saying. You're saying, oh, because they're right angles, look across. These are equal. No. Nope, can't do that because those aren't central or inscribed. Okay? All right. What's up?
EW is congruent to WF.
Not yet. We're gonna get there. Here's what Castaneda. So EW congruent to WF. Not yet. But tell me the theorem you used to say that.
Radius perpendicular to chord bisects the chord.
You guys that were here yesterday, remember that theorem? That was theorem number 4, the one we spent a lot of time on. A radius perpendicular to a chord. Ready? A radius perpendicular to a chord does what to the chord? Again, what does it do to the chord? One more time. What does it do to the chord? Bisects it. Why am I spending so much time on that and having you repeat it? It bisects the chord. It doesn't say these two pieces are equal. All it says is, and this is the next step, all it says is OC bisects that chord of EF. That's what that theorem says. The theorem does not say, oh, the two little pieces are equal. That's not what it says. So here it is from yesterday. Diameter. You can put in the word radius. I don't care. It's part of a diameter, right? Diameter perpendicular to a chord bisects the chord. That's how we use this theorem. We do not use it to say the two pieces of the chord are congruent. We do not use it to say that. And again, you guys that weren't here yesterday, this is one of the 4 we went over yesterday. But you guys have been doing this for 10 units now. Now, after we write that, what allows us to say, oh, now segment EW and WF are congruent now? What allows us to say that? Not a circle fact, but just. Don't forget where you've been. Thank you, Haley. Definition of bisects. There you go. All right, so again, I'm going to keep stressing this. This theorem I showed you guys yesterday only shows the chord is getting bisected, not the pieces of the chord are congruent. And there you go. Good job, everybody. That gives me another side. I think the triangles are now congruent. Triangle EWC congruent to triangle FWC. Reason? Anybody? Reason? Steve? Side angle side, yep. And then the triangles are congruent, so any corresponding angles or sides will be because of CPCTC. There we go. CPCTC. Whoo! There we go. One down. I know we only used one circle fact, but it was a big one. Any questions from you guys there? Going. You ready for a little entree here now? The main course. Oh, I love this one. It's a great proof. AV congruent to DE. Is there any importance that they told me this was circle C? What can you get? Doyle, what? Who cares?
CE and AC are radius.
Oh, so yeah, C's the center. So now I know all those are radii, which maybe might help me. We'll get to that. And finally, proof statement. Segment BX, that's not a chord, that's not a radius, I don't know what to call it. BX, congruent to dy, not going to be true until.
The triangles are.
All right, there you go. Let's do it. And why do I love this so much? You guys don't have anything. I started you off with a blank slate. I gave you no sides or no angles, so that is on you. And this is where I'm going to start calling on you guys. Give me a pair of sides or angles you know are congruent, and please tell me why you know they are congruent. And it doesn't have to be a circle fact. It can be, but it doesn't have to be.
Oh, yeah.
Oh, here we go. Anything congruent up here. Anything congruent. Let's start it off right. Amy?
XC and CY.
There you go. We'll start it off there. XC, side XC is congruent to side CY. Back yourself up, Amy.
All radii in a circle are congruent.
Good job. One side down. All right, good job. What else do I have up here that I could use? How else could I get sides or angles here? What else do you see up here? Let's roll. There we go. Haley, what else do you see?
Could you subtract AC, or could you subtract AB from AC? And
Yep. But not until you tell me. I can't do subtraction yet until you tell me what two pieces are equal.
AC and CE.
Yep. Everyone see, we're going to do a little subtraction here. Actually, you could put that in step 3. Is everyone all right if I put it in step 2? Because it's going to have the same reason why the other two are equal. If you want to make your proof one step longer, make yourself look a little smarter. Go right ahead. AC congruent to CE. Yep. And does everyone now see the subtraction? Good job, Haley. Yep. That was a tough one to see. So now we're going to do AC minus AB equals CE minus DE. Some of you might think, oh, you can do subtraction in circles? Guys, all a radius is all these are segments. You can subtract segments. I don't care if they're inside or outside a circle. You can subtract them. That's fine. And hey, we're on unit 10, and guess what's still not changing from the past 9 units? Right after subtraction, because it's going to come? Substitution, not changing, no matter how deep in the year we get. So what's that going to be? BC congruent to CD. You could still subtract inside a circle and add too. All right, another pair of sides down. One more pair. And I hate to, I don't like to use the term common sense, but it can't be another pair of sides because that's the sides we're trying to prove congruent. So it's probably going to be a pair of angles, right? Can't be a third pair of sides because we're trying to get BX and DY congruent. And I always feel so bad here. It's just, you guys are thinking too hard at this. It's been a while too since we probably used these two. But don't overthink it. Don't make your life difficult. Where are those angles I know I need? Olivia?
CX and YCD.
Because they're what?
Vertical.
Yeah. Reflexive is usually the number one thing people go to. And number 2 is probably, vertical angles. Don't forget about them. Good job, Olivia. Angle XCB congruent to angle DCY. Now the catch is, are you still spelling it incorrectly? Not CLE. What? What am I doing? I have the wrong ones marked. No, I'm good. I forgot to mark these. All right, I think we got enough info now. That gave us a pair of angles. Now I could say the triangles are congruent. finish this strong. What reason are they congruent for? Gabby. Side angle side, thank you. And then if the triangles are congruent, I think bx will be congruent to dy because of, finish this proof for me here. Get back to you, Zoe. 3. Aiden? Yeah. Good. Yes, Matt?
Wait, since we know that BC and CD are congruent,
Yep.
using the rule that we talked about earlier, could you say that they're congruent or no?
What rule?
Like they're equidistant from a point?
Where's your chord, though?
Well, it's like half of the chord.
It's not a chord, though. It's not a chord. It's got to be a chord. The endpoints have to be on the circle. Okay? Okay, so that's dy and xb. I don't even know I don't have a name for them. They're not chords. They're not radii. They're not diameters. I don't have a name for them. They're segments to me. That's it. Okay? Anybody else? All right, how about a little dessert to finish this off? And how about that proof statement? Changed it to similar on you. All right, we don't need to go nuts. How many ways were the proof triangles similar? 3.5, like I remember. Yeah, we got that half in there. But we are doing a proof though. So 3.5 really only became 1. And what was that method? To prove triangles similar in a proof. Probably, yep. Angle. So I need your help finding 2 pairs of congruent angles between those. So I don't care about AT equal AT. Sorry, kids. Don't care this time. All right. I need 2 pairs of congruent angles. Can we start here? If T is the midpoint of arc CD, T, midpoint of arc CD, what 2 arcs have to be equal then? There's a reason I gave that to you. What 2 arcs are congruent up here? Let's go next time, maybe. Oh, back here, Haley. What 2 arcs?
CT and TB.
Good. Make sure we got the arc symbols going. Arc CT and TB. Definition of a midpoint. And I will let you guys simmer on this, look at it a little bit more. Where can you find me 2 pairs of congruent angles? Or just one. Heck, I'll take 1 for now. And the 1 pair, you did not have to be here yesterday. We went over it before break, how to get the 1 pair. The other pair, yeah, you had to be here yesterday to know this one. And they're both circle facts.
What do you think?
Wait, what's
CT congruent arcs.
Yeah.
Congruent arc.
Or no, the angles are just the same degree as the arcs. So the arcs
Oh, so these two.
It was like from wide. No,
Yeah, I know. Strong, same form and congruent, but that's not.
You don't know.
Oh, it's-
What was that?
How are we looking? Anything you want to contribute here? Any angles you want to tell me about? Even if you don't have the theorem word for word right, that's fine. Josh?
Angle CAT is congruent angle TAB.
Good. Right there. Okay, here's my first pair. I will write down angle CAT. Everyone take a look. What type of angle is that? Inscribed. And TAB, which is also inscribed. Why are they congruent? They're both drawn to 2 arcs that are congruent. All right, this was theorem 1 we went over yesterday for you guys that weren't here. Angle CAT congruent to angle TAB. And here's what we'll write. We actually did it for you guys that were here yesterday. We did it for central angles, and I wrote, and right next to it, we could also do this for inscribed. Congruent arcs, which is what I have in step 2. Congruent arcs imply I have congruent One more time, what type of those angles? What type of angles are they? Inscribed angles. So if I have two arcs that are congruent, that means any inscribed angles drawn to them are congruent. All right, thank you, Josh. Perfect. All right, so I have one more pair of angles left. Nobody cares about the sides, just the angles. Anybody see any other angles up here? Or you marked your diagram with something, and it's true. You might not know why, that's fine. Continue, what do you have?
Angle ACC and GT, or ATB.
Okay, yep.
Congruent.
Okay, why? They are going to be congruent.
Because they're both right angles.
That's the part I wanted to hear. Ready? Here you go. Angle C is a right angle because of a circle fact. So is angle ATB is a right angle, but for two different reasons. So it's going to require me to do two separate steps. Angle C is a right angle. Why is it a right angle? This is I think it was a day 4 fact. Many days ago. What type of angle? I don't want to hear a right angle. What type of angle is angle C in the circle? That's called an. Same as those two. That's an. It's an inscribed angle drawn to. I'll help you out. Look where it's drawn to. Here's angle C, drawn here. Where's it drawn to? What's AOT called again? A diameter, or you can put semicircle. So an inscribed angle drawn to a diameter. A little more bolder there. Is a right angle. Good there? All right, step 5, let's go to the other angle now. Angle ATB. That's a right angle for a different reason. This is when we went over tangents, the day we did tangents. Radius, OT, radius drawn to, what did we call point T again? Point of tangency, yep, radius drawn to point of tangency forms a right angle. Okay. Great proof. It uses 3 big circle facts. 2 ways you can get a right angle out of a circle. And now, they're not similar yet until you tell me these 2 right angles are congruent. Whew. And that's how you get the second angle. And now just finish it up. Tell me they're similar. Whoa, whoa, whoa. How many of you put the congruent symbol there? Have some self-respect. We do it, all right? Okay, I don't forget. Everyone good? Okay. You got 4 proofs tonight. Let's get going. You got plenty of time to practice. If you get stuck, call me over. If you can't find that second, third pair of angles or sides, call me over. Because I'm pretty sure all 4 proofs involve you proving triangles at least first before doing something else.